Hello there, so let's get started with the next set of operations on the pointer. So in this video we are going to discuss about the arithmetic operations on the pointer. So we'll see how we can apply the arithmetic operations on the pointer, which are the valid arithmetic operations on the pointer and which are not valid arithmetic operations on the pointer, and how it makes sense to apply arithmetic operations on the pointer. So these are the things that we will discuss in this video. So let's first discuss what are the valid arithmetic operations on the pointer. So when it comes to arithmetic operation, we can actually apply addition operation, we can also apply increment operation, we can also apply subtraction and decrement operation on the pointer. So addition, increment, subtraction and decrement, these are the valid arithmetic operations on the pointer. So let's see how we can apply these operations on the pointer, and we'll then discuss about how it makes sense to apply arithmetic operations on the pointer. So for explaining all this stuff to you, what I have done on the whiteboard, I have drawn one random access memory. Okay, you can see over here random access memory, as we have discussed multiple times, it is nothing but a huge array of bytes, and each and every byte will have a unique address. So you can see in the diagram, I have a RAM and I have multiple bytes in the RAM, and you can see for each and every byte I have given a unique address. So the address is starting with 100, then the next byte will have address as 101, 102 and so on. Okay, so this is my random access memory. Now what we will do for our example, we will declare one integer variable and then we will create pointer to that integer variable, and then on that pointer we will apply all the arithmetic operations. Okay, so as the first step, what we will do, we will declare one variable of type integer. So let me declare one integer variable. So let me write int, let's say var, and also let's give some initial data to it. I am writing int var is equal to 10. Then let's create a pointer of integer type. So I write int star ptr is equal to address of var. Okay, now observe very carefully what is happening. See, we are creating one variable, that is var, and we are storing data, that is 10 in it, right? Now what is the size of this variable? When it comes to integer variable, the size is going to be 4 bytes. Okay, so now let's assume that this variable is getting stored over here, let's say in these 4 bytes. Okay, so let me put this 10 data over here. Okay, so this is 1 2 3 4. See, so this variable, that is var variable, is getting stored over here in these 4 bytes. See, integer takes 4 bytes of memory, that's why this variable is going to be stored in these 4 bytes. Now whenever we write int star ptr is equal to and var, so what happens is we are storing address of var in ptr. Okay, now what is the address of var? See, actually if you see, var is a variable and it is taking 4 bytes of memory. So actually it has 4 different addresses, 100, 101, 102 and 103. But out of which, when we talk about address of var, we just talk about the first address from which the variable is getting started. We call that address as base address of the variable. Okay, so whenever we write address of operator, we actually get base address of the variable, because if variable has 4 byte of size or 4 byte of memory, then in that case it will have 4 addresses. But we just care about the first address from which the variable is getting started, and we call that address as base address. So just remember this thing, keep this thing in your mind, that whenever we talk about address of operator, it always returns the base address of the variable. Okay, so now what will be stored in the pointer ptr variable? It will basically hold value as 100, because 100 is the base address of var variable. Now let's assume that this ptr is also taking 4 byte of memory. Okay, this pointer is also taking 4 byte of memory. See, just for this example, just assume this. We know that on modern machines it is nowadays taking 8 byte of memory, but for now let's assume that it is taking 4 byte of memory, and let's assume that these are the 4 bytes in which the data of pointer is getting stored. Okay, so let me write it over here. See, here 100 will be stored, 1 2 3 4. These 4 bytes will be consumed by this pointer variable. So let me write variable name on the top. So this is the space getting consumed by ptr variable, and this is the space which is getting allocated for the var variable. Okay, so this is the structure that is created in the memory. See, we can't predict on which places in the RAM the variable will be allocated. So So it depends on multiple factors. It is the OS's decision which will basically decide where to allocate the memory for a variable. Okay, so we can't predict. So maybe it can happen that var is getting created over here, and then this PTR will get created just after var. And maybe the PTR can get created by leaving some space in between, so we can't predict. So for now we are writing structure like this, or we have created structure like this. Now let's understand the first arithmetic operation on the pointer, that is addition operation. Okay, so let's start with the first operation, that is addition operation. See, when it comes to the pointer, we can apply addition operation on the pointer. Now in addition operation we can just add constants to the pointer. See, this statement is very important. When it comes to the addition operation, we can add only constants to the pointer. We cannot add two pointers. Okay, so let's say you have two pointers of integer star type. One is ptr1 and another one is ptr2. You cannot write ptr1 plus ptr2. It is illegal, or it is invalid. But you can write ptr1 plus 2. You can write ptr1 plus 10. You can write ptr1 plus 100. So you cannot take sum of two pointers, but you can add a constant to a pointer. Okay, so now in our example, let's see how we can perform the addition. So see, if I write cout ptr, then what will be the output? So basically the output of this line will be 100, because right now ptr is storing 100 as its value, right? Let's apply addition operation. So if I write cout ptr plus 1 followed by endl, now just try to think what will be the output of this line. See, I'm trying to write cout ptr plus 1, where ptr is a pointer and it is of type int star. Okay, and I'm trying to add 1 to it. So just try to tell me what will be the output. What will be the output of this? If you are thinking that the output will be 101, then it is absolutely wrong. Okay, see, pointer is a special variable. It's not like your integer or float variable. It's a special variable, and that's why whenever we write arithmetic operations on the pointer, they behave a little bit differently as compared to our normal variable. This is very important thing. Just focus very carefully. This is very important. So my statement is, whenever we apply arithmetic operations on a pointer, then the arithmetic operations behave little bit differently on a pointer as compared to normal variables of type integer and float. Okay, now let's discuss how the arithmetic operations behave differently on pointer. What will be the correct output of this? So the correct output of this statement is nothing but 104. So basically this will result in output as 104. Now why we will get 104 as output? So let's understand this by looking at this diagram. Just tell me how many bytes the variable is taking, which is pointed by ptr pointer. It is taking 4 bytes of memory, right? These are 4 bytes of memory. So the variable which is being pointed by ptr pointer, it is consuming 4 bytes of memory in a RAM, right? Right now ptr is pointing at 100 locations. So right now ptr is pointing over here. This is the location where ptr is pointing, and from that location next 4 bytes are consumed by the variable, okay, to which ptr is pointing right now. So basically we know that type of ptr is int star, and as it is its type is int star, that means it is pointing to the integer type variable, and its base address to which it is pointing is 100, and the size of the variable is 4 bytes. So a compiler can understand that it is now pointing to 100, and the variable type is int. So the variable is present between 100, 101, 102 and 103. Okay, now when we write ptr plus 1, instead of making its value, or instead of giving us result as 101, what compiler will do is, compiler will take us to the next integer in the memory. See, right now this is the integer that I have from 100 to 103. Now if there is one adjacent integer present in the memory, where it can be adjacent integer, I'm saying adjacent integer, so where it can be, see, it will be between 104 to 107, correct? See, we have one integer from 100 to 103. So the next adjacent integer just after the current integer, it will be between 104 to 107. So whenever we write ptr plus 1, what the compiler is going to do? The compiler is going to take us to the next adjacent integer, and that's the reason the next adjacent integer, as it is starting with 104, that's why when we write ptr plus 1, the answer of that will be 104. I think now this is very clear to you. So whenever you write ptr plus 1, it will not just increment its value by 1. It will so the value will depend on the data type. Okay, what will be the output of this statement will depend on the data type. So in case of integer variable, if the pointer is of type integer star, so when we do ptr plus 1, the pointer will be incremented by 4. Okay, if the pointer is of type char star, where it is pointing to a character variable which just take 1 byte of memory, then in that case, if we do ptr plus 1, so in that case the pointer will be incremented only by 1. Okay, if the pointer is of type double star, and if we do ptr plus 1 in that case, then the pointer will be incremented by 8 if we do ptr plus 1. So what is the catch over here? What is the basic logic over here? So depending on the type of pointer, the result of addition will change. Okay, so depending on the type of variable to which it is pointing, and depending on its size in the memory, I will say the result will vary. So in case of integer, as integer consumes 4 byte of memory, so when we add plus 1 to the pointer, in that case it will be incremented by 4. If the pointer is to character type variable, then in that case it will be incremented just by 1. And if the pointer is of type double, then it will be incremented by 8 if we add 1 to the pointer, or if we write ptr plus 1. Okay. So what we can do is we can create a general formula for for addition on a pointer or addition operation on the pointer. So let me just write the formula. Let me erase these lines. So what is going to be the formula? So whenever we are writing ptr plus 1, okay, so the output of it is going to be the initial value of ptr. So I'll say initial value of ptr plus size of data type to which ptr is pointing, right? Size of the data type to which ptr is pointing into, I will say, 1. When we are doing ptr plus 1. See, so initial value of ptr is 100 initially, then we are writing plus size of the data type. So if it is pointed to integer, then size of the data type is 4 into 1. So 4 into 1 is 4. So then the value or updated value will become 100 plus 4, 104. Okay, now let's write the same, or let's see how it will work if we write ptr plus 2. So in this case, initial value of ptr is 100 plus size of the data type is 4 into 2. So then the result that we will get is going to be 108. Okay, so how we are getting the result? See, when we are adding 2 to it, so the pointer will take us to the next adjacent int. So the next adjacent int is at 104 location, and next adjacent int is at 108 location. Okay, so basically whenever we are adding 1 to it, it is incrementing the pointer by 4. When we are adding 2 to it, it is incrementing the pointer by 8. As simple as that. Okay, and depending on the size of the data type, basically this answer will change. So if the pointer is to a character type, then the size will be 1. So that's why in that case, if initial value of ptr is 100, so after incrementing it or after adding 1 to it, it will become 100 plus 1 into 1, that is 101. Then if we are adding 2 to it, then it will become 100 plus 1 into 2, that will become 102, and so on. I mean, you can keep on adding numbers to it. And similarly for the double, it will be 100 plus 8 into 1 when we are adding 1 to it, so it will become 108 directly. And when we are adding 2 to it, so it will become 100 plus 8 into 2, so it will become 116. Okay, so in this way basically the addition operation works. Now as we can add a constant to a pointer, similarly we can increment the pointer. Okay, so we can, instead of writing ptr plus 1, we can write ptr plus plus. and this is nothing but an increment operation. Okay, I don't think we don't need I don't think we need too much explanation of this. See, instead of writing PTR is equal to PTR plus 1, if you want to change the value of PTR with the updated value or with the value that is PTR plus 1, instead of that, what you can do is you can directly write PTR plus plus. So basically PTR plus plus will increment the value of PTR by 1. Okay, so whenever I am saying that PTR plus plus will increment the value of PTR by 1, it doesn't mean that PTR, if it is 100, then it will become 101. Okay, the same formula will be applied. See, when PTR is 100 and if PTR is of type int star, then PTR plus plus will make it 104. Okay, if PTR is of type char star, then in that case PTR plus plus will make it 101. Okay, so in this way basically it will work. So I hope now you are clear with the basic idea about how the addition operation works on the pointer. Okay, so let's move ahead and let's see how the subtraction operation will work on a pointer. So let's start with the next operation on pointer, that is the subtraction operation. Similar to the addition operation, in the subtraction operation we can subtract a constant from a pointer. Okay, and there is another interesting thing about the subtraction operation. In the subtraction operation we can also subtract two pointers, that is also allowed. See, in addition we cannot add two pointers because it doesn't make any sense. See, pointer is the address, and when we are adding two addresses it doesn't make any sense. But in subtraction operation we can actually subtract two pointers, and I will tell you what exactly do we mean by subtracting two pointers, or what is going to be the result of subtraction of the two pointer. I am going to discuss about that. Right now don't worry about it. Right now just start with the simple variant of the subtraction. It is basically subtracting a constant from a pointer. Okay, so similar to the previous example, let's say if I write PTR minus 1, then what will happen? See, in this case PTR is of type int star. Okay, it is of type int star. So when I am writing PTR minus 1, what will be the answer? See, right now PTR is 100. So what will be the answer of PTR minus 1? It will be 96. 4 bytes will be subtracted because as pointer is of type int star, that's the reason 4 bytes will be subtracted from it, because size of the integer data type is 4. Always remember, whenever we are performing any arithmetic operation, it will always work in terms of data type size, okay, or size of the data type to which the pointer is pointing. Okay, so in case of int star type pointer, it is pointing to int, so that's why it will always work in terms of 4 bytes because size of int is 4 byte. Okay, if it is pointed to character star, then it will always work in terms of 1 byte. Okay, so this is something which you have to keep in your mind. So answer of PTR minus 1 will be 96 because 100 minus 4 is 96. What will be the answer of PTR minus 2? PTR minus 2 will be 92 because PTR minus 2 will basically subtract 8 from 100. Okay, and if we subtract 8 from 100, then it will become 92, right? So in this way the subtraction operation works. Alright, now as I have said, in subtraction there is one more interesting special thing about the subtraction, that we can also subtract two pointers. Okay, so let's assume that we have two pointers. Let me just erase this thing. Okay, so let's assume that we have two pointers. One is PTR1, so let me draw it over here, PTR1, and another one is PTR2. Okay, let's assume that PTR1 is storing address as 100 and PTR2 is storing address as 104. Okay, and both of these pointers are of type int star. Okay, so both of them are of type int star. So in C++, what you can do is you can subtract two pointers of the similar data type. If the two pointers are of similar data type, then you can subtract them. And so I can write something like this. I can write PTR2 minus PTR1 and just try to guess what will be the output of it. Just try to pause the video and just try to guess what will be output of it. If you are thinking that the output will be 4, then it is wrong. The output of PTR2 minus PTR1 is going to be 1. Okay, see, this is very important. Output of PTR2 minus PTR1 is going to be 1. Now why this is going to be 1? See, whenever we write subtraction or whenever we subtract two pointers, the compiler is going to give us the output which will indicate how many integers can fit in between these two ranges. Okay, so PTR2 is pointing to 104, or it is having value as 104, and PTR1 is having value as 100. So just tell me how many integers can fit between 100 to 104, where 104 is excluded from the range, okay, and 100 is included in the range. So in 100 to 103, how many integers can be included, or how many integers can fit? So the answer is very easy. Only one integer can fit in between, because one integer takes 4 bytes of size, and if you count 100, 101, 102, 103, these are the 4 bytes. So in this range only one integer will fit, and that's the reason when you subtract two pointers, or when you are subtracting PTR2 and PTR1, you are going to get answer as 1, because in 100 to 104 range only one integer is going to fit, and that's why the output that we are getting is 1. Okay, so it's very easy. Similarly, let's assume that PTR2 value is, let's say, 108. Now tell me, if I subtract PTR2 and PTR1, what will be the output? It is very easy. We will get output as 2, because in 100 to 107 range, how many integers can fit in? 2 integers can fit in. See, you can observe it over here. See, 100 to 103, one integer, 104 to 107, another integer. So 2 integers can fit in, so we will get output as 2. Okay, so if I want to make a formula, if I want to make a generic formula out of it, so what I mean, for the output of subtraction of 2 pointers, then what will be the formula? It will be the difference between the addresses. So difference between the addresses, so in this case the difference is going to be 8 divided by size of the data type of a variable to which the pointer is pointing. So what is the size of the data type of the variable to which the pointer is pointing? It is 4. So that's why if you do the calculation, then you will get a 2 as the output, and in this way the subtraction operation works on a pointer. Now if you want to write something like PTR is equal to PTR minus 1, instead of writing PTR is equal to PTR minus 1, you can write PTR minus minus, and this is nothing but decrement operation. Okay, so in order to decrement the pointer by 1, you can write decrement operation, and again when I am saying 1, basically it will mean in terms of size of the data type. Okay, now let's quickly move to the Visual Studio Code and let's see it in action. Let's write a code for it and let's see how it is giving us the output. Okay, whatever we have discussed on the whiteboard, is it same working on the Visual Studio Code or not? So let's quickly switch to the VS Code. Okay, so now we are in VS Code. So to start, let's create one variable, and also let's create one pointer to that variable, and on that pointer we will apply all these operations. Okay, so we already have one pointer with name PTR, so I will just comment out this code, entire code. Okay, so these operations will not happen again. So we have this PTR pointer. Okay, so let's see. Let's first print value of PTR. So I'll write cout PTR followed by endl. Then what I will do is I will write cout PTR plus 1. Okay, now let's see the output. So let's first quickly compile g++ pointers, the pointers operations.cpp. Okay, and then let's execute this. Okay, so you can see that we are getting output as E14 for the first line. So whenever we are printing PTR, we are getting E14. Okay, and when I am writing PTR plus 1, just observe carefully, we are getting E18. So this E18, you can observe that there is 4 byte difference in them. Okay, so E14, if you subtract from E18, then you can see the answer that you get is 4. Okay, so basically there is a difference of 4 bytes in between them. Alright, so in this way the addition operation is working. Let's see what we get as the output if we do PTR plus 1 again. Just try to tell me what will be the output if we write PTR, cout PTR, then cout PTR plus 1, and then again we write cout PTR plus 1. Will it be, so let's assume that, let's say its output is 100 and let's say its output is 104. So what will be the output of this line? Will it be 104 or 108? See, this is a very simple question. I am just trying to confuse you. I know that you will not be confused. See, the output of this line, that is 29th line, will be 104 only, because in this line we are not storing the updated value of PTR back to PTR. So that's why whenever we are writing this line, 29th line, so in this case PTR is still 100. Okay, So in this case the output will be again 104. But on line number 28, instead of cout ptr plus 1, if I do something like this, ptr is equal to ptr plus 1, then in that case what will happen? In this case, first we are printing ptr, let's say if it is 100, then we are writing ptr is equal to ptr plus 1. So 100 plus 1 will be 104. So this 104 is getting stored in ptr. So now the ptr value has got changed. Now ptr has become 104. And then if I am writing cout ptr plus 1, then in this case the output that I will receive or I will get is going to be 108. Okay, so this is how it is little bit different from the previous example. So if you have to do something like this, that is ptr is equal to ptr plus 1, before that let's first execute this code. Let's see what we get as the output. So you can see that initially we are getting E14 and then we are getting E1C. Okay, so you can see there is a difference of 8 bytes between them. So that's why the pointer is incrementing by 8 bytes. Okay, now if you want to write something like this, that is ptr is equal to ptr1 plus 1, instead of writing it like this, like ptr is equal to ptr plus 1, you can also write it in short, that is like this, ptr plus plus. Okay, so you can also write it like ptr plus plus. So when we write ptr plus plus, ptr will be incremented by 4 bytes if ptr is of type int star. Okay, if you write ptr plus plus and ptr if it is of type char star, then it will be incremented by 1 byte. Okay, so we have already discussed this thing. So let's see what we get as the output. Let's compile it again. You can see that we are getting the same output, that is E14 and E1C. Okay, so we are getting the same output. So in this way, basically ptr plus plus is very similar to ptr is equal to ptr plus 1. Okay, now let's see the next operation, that is subtraction operation. So initially I am printing ptr. Let's print ptr minus 1. Let's see what we get as the output if I write ptr minus 1. Okay, so you can see that initially the value is E14 and after subtraction you can see that the value is E10. So it is getting subtracted by 4 bytes, or the difference is between the difference between them is 4 bytes. Okay, so in this way the subtraction operation is working. And as I said, we can also subtract 2 pointers. Okay, so let's also see that how we can subtract 2 pointers. So for that what I will do, I will create one more variable, that is b. Okay, and let's create 2 pointers, ptr1 and ptr2. Okay, so ptr1 will point to a and ptr2 will point to b. Okay, so this is the structure that we are creating. Then let's print value of ptr1. So ptr1 is nothing but address of a. And similarly, let's print value of ptr2. So ptr2 is nothing but address of b. Okay, then what we will do is we will subtract ptr2 from ptr1. So I am writing ptr2 minus ptr1 and then endl. Okay, so let's see what we get as the output. See, let's compile this code quickly. Now let's execute it. Okay, so you can see that the address of ptr2, initially the address of ptr1, it is E0C. Okay, and address of ptr2 is E08. Okay, so basically b variable is getting allocated before a variable, and that's why address, if you see carefully, address of b variable is less as compared to address of a variable. So as I said, we cannot predict how the variables will be allocated. We can't actually predict. So here you can observe we are initially declaring a and then we are declaring b, but the addresses that are getting allocated, b is getting allocated first and then a is getting allocated. Okay, so we cannot predict, and that's why you can see over here address of a is greater as compared to address of b. Okay, so when I am writing ptr2 minus ptr1, what is the output that I am getting? -1. Okay, instead of this, if I write ptr1 minus ptr2, let's see what we get as the output. So in this case, if the addresses remain the same, then in this case we should get 1 as the output, because addresses, if you observe carefully, they have 4 byte of difference between them, and when we are subtracting them, how many integers can fit in between the range that we have currently? Only 1 integer can fit in, and that's the reason we are getting 1 as the output. Okay, So I hope now you have got a clear idea about the different arithmetic operations that we can apply on the pointers. Okay, now let's discuss about few illegal operations or illegal arithmetic operations on the pointer. See, we cannot add two pointers. It is not allowed in C++. We can add a constant to a pointer, but we cannot add two pointers. Okay, then we can subtract two pointers. We cannot add them, but we can subtract two pointers. We can subtract a constant from a pointer, that is also valid. Okay, we cannot multiply anything on pointers, so we cannot multiply a pointer with constant, or we cannot multiply two pointers. We cannot divide two pointers. We cannot take modulus on the pointers. Okay, so the only valid operations on the pointer are addition, increment, decrement and subtraction. Okay, so thank you so much for watching this video. See you in the next video. In the next video we are going to discuss about relational operation on the pointer.